Something on Mars is moving. Not in a blurry rumor, not in a strange shadow from an old photograph, and not in the kind of internet mystery that disappears when you zoom in too far. This phenomenon was photographed from orbit, measured over multiple seasons, tracked for years, and studied by some of the sharpest cameras humanity has ever sent to another world. Dark streaks appear on Martian slopes when the planet warms. They slowly creep downhill, growing longer as the temperatures rise. Then, when the cold returns, they fade away, only to reappear the following Martian summer. For a planet that is supposed to be frozen, dry, irradiated, and almost completely dead on the surface, this should not be happening. Mars is not expected to have liquid water flowing across its slopes today. Its atmosphere is far too thin, its temperatures far too extreme, and its surface too hostile for anything wet to survive for long. Yet the photographs exist, the measurements are real, and after one of NASA's biggest announcements of the decade, the story became strangely quiet. Whatever is moving on Mars may be one of the most important mysteries ever photographed on another planet. The spacecraft responsible for discovering this mystery is the Mars Reconnaissance Orbiter. It arrived at Mars in 2006 carrying one of the most powerful cameras ever sent beyond Earth, the High-Resolution Imaging Science Experiment, better known as HiRISE. The name may sound technical and unremarkable, but the instrument itself is extraordinary. From hundreds of kilometers above the Martian surface, HiRISE can capture details as small as a kitchen table. It can even photograph the tracks left by rovers in the dust and spot NASA's Curiosity rover as nothing more than a tiny dot on the landscape. In many ways, it is humanity's most powerful eye watching Mars from orbit. In 2011, that remarkable eye noticed something completely unexpected. An undergraduate researcher named Lujendra Oja was comparing images of Martian slopes taken during different seasons when he spotted dark, narrow lines running downhill from crater rims and steep cliffs. In one image the streaks were visible, in another they had faded away. Later, they appeared again in almost exactly the same places. These were not random marks left by shifting terrain. They followed a clear seasonal pattern. The mysterious streaks appeared on warm, sun-facing slopes during the Martian summer. As temperatures increased, the streaks grew longer, stretching farther downhill. When the planet cooled, they disappeared once again. Scientists named these features recurring slope lineae, or RSL. Outside the scientific community, however, they became known simply as the moving streaks. From the very beginning, they looked disturbingly familiar. On Earth, when dark streaks appear on a hillside, grow downhill, and return during warm seasons, the explanation is usually straightforward. Something wet is flowing. The problem is that Mars is not Earth. Its atmosphere is less than 1% as dense as Earth's at sea level, and its average surface temperature remains well below freezing. Under such conditions, any ordinary liquid water exposed on the surface should freeze, evaporate, or boil away almost immediately. That is why the recurring slope lineae became such an important scientific mystery. They behaved exactly like flowing water in a place where flowing water should not exist. At first, scientists remained cautious. Dark streaks alone were not enough to prove the presence of water. Dust and sand can also move. Slopes can collapse, and fine layers of Martian regolith can slide downhill, creating similar-looking features. Mars is covered with powdery material capable of deceiving even experienced observers. To solve the mystery, researchers needed chemical evidence rather than visual clues alone. That evidence arrived in 2015. Another instrument aboard the Mars Reconnaissance Orbiter detected hydrated salts, including perchlorates and chlorates, in the same regions where the dark streaks appeared. These chemicals are especially important because they can dramatically lower the freezing point of water, allowing extremely salty liquid brines to remain liquid at temperatures far colder than ordinary water could survive. Suddenly, the mystery became far more significant. If perchlorate brines were forming on Martian slopes, then Mars might still possess liquid water on its surface today. Not billions of years ago during its ancient past, not hidden deep beneath the ground, but actively appearing in the present day. That possibility transformed the discovery from an interesting geological puzzle into one of the most exciting questions in planetary science. Where there's liquid water, even water that is freezing, salty, and toxic, the question of life inevitably follows. On Earth, microbes thrive in deserts, inside salt crystals, in acidic lakes, beneath frozen soils, and within brines so hostile they seem almost designed to destroy life. Yet life continues to endure. It hides, adapts, and finds ways to survive in environments once thought impossible. If Mars still has places that become wet, even for a short time and only during certain seasons, then the red planet may not simply be the fossilized remains of a once habitable world. It may still possess a faint but unmistakable pulse, suggesting that Mars is more active, and perhaps more mysterious, than anyone ever imagined.